Look at this narrow gap of water. This is the Strait of Hormuz. Right now, 20% of the global economy's oil is funneled through this exact choke point. The primary targets moving through these waters are supertankers. These are multi-billion-dollar giants that carry our energy supply, but they are also slow-moving and almost completely defenseless in such a tight space. Waiting for them is a swarm of mosquitoes, cheap $5,000 fiberglass speedboats armed with basic rocket launchers. They hide in plain sight, blending into civilian fishing traffic until the moment they strike. Against a swarm of 100 mosquitoes, even the most advanced navy in the world faces a humiliating reality. You cannot destroy what you cannot single out. Standard naval engagement rules provide no answer to this level of clutter and cost disparity. To protect the waterway, the U.S. Navy shifted from traditional power projection to a more deceptive, predatory approach. The strategy starts with a high-stakes gamble. The Navy deploys a lone guided missile destroyer. No escort, no air cover. To the hostile Mosquito fleet watching from the coastline, this looks like a catastrophic error. A multi-billion-dollar prize, totally isolated and ripe for a swarm ambush. But that isolation is an engineering feat. The ship acts as the lethal endpoint for a massive, invisible digital network. Because the Earth's curvature blinds surface radar, the Navy uses a high-altitude eye, the E2 Hawkeye. This diagram illustrates why the plane is necessary. Because the Earth is curved, a surface ship's radar waves eventually travel out into space, missing low-profile boats. The Hawkeye bypasses that physical limit, looking down from above and feeding targeting data directly to the destroyer's computers. The bait is a perfectly calibrated sensor trap. The Navy invites the ambush specifically so the enemy attacks exactly where and when the digital network is ready for them. The trap is set, and the Mosquito swarm launches into the fog, fully believing it have the element of surprise. Before the boats can fire, the destroyer activates its electronic warfare suites. It projects a wall of electromagnetic energy that instantly scrambles the swarm's GPS and communication channels. In seconds, a highly coordinated attack formation devolves into a disorganized mess of fiberglass boats, unable to talk to each other or navigate the open sea. For any boat that breaks the fog, they meet the wall of lead, the Phalanx CIWS. This rotary cannon fires 6,000 solid tungsten rounds every minute, physically shredding the incoming boats before they can get into range. The Navy neutralizes the numerical advantage by overlapping digital blinding with kinetic force, ensuring the swarm never reaches its target. You might think the battle ends there, but destroying individual boats on the water is a losing game. Cheap fiberglass is infinitely replaceable. The Navy didn't just want to survive the ambush. They used it as a tracking exercise. This map shows the ultimate move. The Navy takes the electronic signatures of every retreating boat and traces their movement paths backward to the mainland. The tracing lines converge on hidden mountain hives, the exact fortified bases where the fleets are manufactured, stored, and launched. Once the source is located, the Navy retaliates with 2,000-pound bunker busters, burying the remaining Mosquito fleet inside their own production tunnels. Victory in asymmetric warfare relies on using the skirmish at sea to pinpoint and destroy the enemy's production on land. Today, the Strait of Hormuz has been transformed. It operates as a highly monitored kill box where every movement is indexed. The U.S. Navy sails into the line of fire because they aren't the prey. They are the trap.